Alright, hello everyone, this is Andrew Lawrence from Team 1323 Madtown Robotics. Today I'm going to make this video to show you how to model gears and simple gearboxes in Solidworks. Alright, let's get started. Before we start doing the actual CAD, I'm going to go over a little bit of science around gears just so you can get the terminology down. There's a few ways you can define a gear. Gears are defined by tooth count, which is, as the name suggests, how many teeth they have. They're defined by diametrical pitch and pitch diameter. Pitch diameter is essentially the diameter, or it's the point at which two gears mesh. Diametrical pitch talks more about the spacing between each teeth. And we have the outer diameter, which we're going to work a lot with, which is essentially the outside of the gear. If you were to look at a gear as a circle with teeth, the outer diameter would be the very outer point of the teeth. That's the circle that creates. The pitch diameter I'm going to talk about, but I don't personally use it too much. Like I said earlier, that's the point where the gears mesh. Diametrical pitch is a number. In FRC, most of our diametrical pitches are 20, and that's going to just tell us how close together our teeth are and how large they are. There are 32 DP. DP stands for diametrical pitch gears. West Coast Products sells 32 DP gears. The larger the DP, the smaller the gear, but it also says about the smaller the tooth size, and that can make it slightly weaker. I'm not going to go into that in this video, but maybe later on. Alright, so we got that covered. I mostly use the outer diameter because when modeling everything and I want to know exactly what space my gear takes up, if I use the pitch diameter, there's a little bit of gear tooth that I'm missing technically in my model, so I like to model the whole gear. To make up for not having a pitch diameter, I'll just use the center distance and I'll add a few thousandth, and I'll go over that when I do that. Alright, just to get right into the CAD, I'm going to go select a plane. My goal here is I'm going to make a really simple gearbox plate that will show the model of the interaction of two gears, a 13-tooth gear and a 23-tooth gear. And they're both going to be 20 DP gears. I'm going to show you how I would model that, so hopefully you can understand it a little bit better. So first thing I do is I'll make a circle. I'm going to start out my origin, because that's where I should start most of your sketches in SolidWorks. And of course, this blue, I can't drag it around, but I can increase the diameter, so it hasn't been defined yet. So I need to define the circle's diameter. So that the diameter I'm going to define is the outer diameter. I'm going to do that by taking the outer diameter formula, which I'm going to put in the smart dimension. That's the word, forgot it. You won't be able to see this. I don't know why Open Broadcast software won't show it. So you just see that I have a dimension there, but it doesn't show that I'm actually editing it. There's an equation for the outer diameter of a gear that I'm going to put in the description of this video. What I would normally do is what you can't see is I'm putting the equation into smart dimension. So what I'm actually going to type in the equation is your outer diameter is equal to your tooth count. So I'm going to say 13 because it's my 13-tooth gear, plus 2, and choose a constant. So there's always going to be plus 2. You're going to divide that by the diametrical pitch. And since this is a 20 DP gear, it'll be 20. So 13 plus 2, the quantity of that, which is 15 over 20. And that's going to show as 3/4 of an inch. And that's going to be my outer diameter. That's the outside of my gear. So now I'm going to draw a center line, because I like connecting my gears by center line just to show the path that everything's going to take. Make a new circle. I'll do the exact same thing, except it's going to be 23 teeth. So I'll make my outer diameter is going to be equal to 23 is my tooth size, or tooth count, plus 2 divided by 20. So 23 over 2 is 25 over 20, and that's going to be 1.25. So 1 1/4 is going to be that size. You can see it's still blue. The sketch is blue because I haven't defined how far apart these gears are. Now, if I model the pitch diameter, and the way I do that is just gear tooth over diametrical pitch, I don't need to add the extra 2. I just set those two tangent and I'd be done. The reason I don't do that, however, is because gears aren't always made perfectly. We like them to be, but they're not. So sometimes they're a little slop, sometimes there's manufacturing tolerances. Sometimes you just need to wear in. And in order to account for that in design, what I do is I add a little bit. I add about 2 to 3 thousandths into the center-to-center distance, and that's what that center line is. Center-center distance of the two gears. So how to find the center distance of two gears, there is an equation for that, and I'll be putting that in the description of this video as well. The way you find that out is, so your center distance is going to be equal to the sum of your two gears. So this is going to be 13 plus 23. And you're going to divide that by twice the diametrical pitch. So divided by 2 times 20, and that's going to be 40. If you were to use a 32 dp gear, you'd be dividing by 64, sorry. And that's going to be your normal equation. That's going to be your basic center distance. It's sum of the gears, teeth, and divide by twice the diametrical pitch. What I do is I go take a step further, and I'll add 2,000. So I'll do plus 0.002. And again, you can't see this, what I'm doing. I'll put it in the description of the video. When I do that, we're going to have our center distance being 0.902. Now without that 0.002, it would be a pretty clean number, 0.9. What that's going to show us is the extra 2,000ths in there, so that 0.2 at the end. And you can see the overlap of the gears. I like seeing the overlap, just showing where they're going to mesh. So this little snowman-like figure here, that's our two gears. Now, of course, we're not done yet. If we're going to make a gearbox, modeling gears is pretty useless. So I usually make most of my gears construction geometry, so I just use them for reference. Let's say I'm going to put my bearings in there. I'll have another video about bearings. But I'll make this one 7/8 of an inch, and can I not make this one 7/8 of an inch, or will that intersect? It'll be fine. Not ideal. This is not an ideal situation, but I'll work with it. So those are going to be my two bearings. I'll just make a really simple, oh whoops, not what I wanted. I'll make a really simple slot just to add some material to this gearbox. And I'll extrude it. It's not an ideal gearbox by any means. Probably wouldn't even run it on a robot. But this is the plate. It's a simple plate. I'm not going to put it into an assembly. I'll do that later on. But if I were to look at the sketch, I can see how the gears would work within it. I have my 13-tooth gear there, my 23-tooth gear here. So that's going to work pretty well. And I know that's going to work because the math all works out. Now, I mentioned earlier the pitch diameters. I don't use them too much, but just to show how they would work, I'll just take away the bearings. Oh, took away the wrong thing. That should not have made it. Oh, I see what it did. Yeah, no, that's normal. Anywho, so these are our outer diameters here. Now what do I play with the pitch diameter? Pitch diameter, as I said earlier, is almost the exact same thing as the outer diameter formula, but it's going to be equal to the tooth count, which is going to be 13, divided by the diametrical pitch. So 13 over 20, that's 0.65, less pretty of a number, but it works. And then pitch diameter, the 23-tooth gear, it's going to be equal to 23 plus 2, or sorry, not plus 2, 23 divided by 20. If you see, these circles are really, really close, and that's because I added the 2,000ths. If I were to go to that center distance and take away the 2,000ths, you see that they are tangent to each other. So that's how the pitch circles work. That's essentially saying this is the point where the teeth would mesh. However, doing that doesn't allow us to add the 2,000ths to account for those manufacturing tolerances, so I don't use them. You can put them in if you'd like. I'd say they're not necessary. Other than that, though, this is a simple gear model. This is going to show you the spacing and location of two gears. It'll say how large they are, and it shows you exactly what space they take up in your CAD model. Alright, that should be it for this video. I hope you all learned something, and I hope this is helpful. Thanks for watching.